Mulan to win here?
Zootopia isn't really lovey-dovey. It's more like Mulan when it comes to the whole action thing, and plus people nearly die.
Okay, so we've got 9 for Mulan and 5 for Zootopia. We'll wrap it up in a few seconds here. So throw in your votes if you have a strong opinion. Mulan is definitely in the winning right now. Hey, Myra, how are you? And also, hey, Mahogany. And I know a couple other people joined. I don't know if I caught everybody who joined. All right, Mulan is going to win. We've got 11 for Mulan and 5 for Zootopia. So we're going to say that Mulan wins that. Okay, I think I know who's going to win this next one, but we'll see. So I'm going to end this poll. Okay, so we are doing Wreck-It Ralph versus Hercules. Wreck-It Ralph versus Hercules. What do y'all think?
Okay, oh my gosh, that one's a tricky one.
We're tied here, 7-7. I thought for sure I know which one would win. Okay, Wreck-It Ralph is now 1 behind. Put your vote in if you want Wreck-It Ralph, because Hercules is now 2 ahead. Anybody else?
That's hard. I mean, because Hades and Hercules is, oh, dude, his character is so...
Yeah, they're hard to compare. I mean, they're completely different movies, aren't they? It's like a different genre.
I have not seen Wreck-It Ralph or any of the Frozen movies. I flat out refused to see the first one when I was in elementary school.
That's crazy.
Because it was playing at my elementary school, and I just told my mom, nope, not doing it. Nope.
Gotcha. All right, we are 1 behind for Wreck-It Ralph, so throw in your votes. I'm going to wrap it up in like 5 seconds, okay? Anybody else for Wreck-It Ralph here? Going once, going twice? All right, okay, Hercules is going to win that one. Let me write that down. So Hercules wins for that. Okay. I think I know. I don't know what's going to win for the next one. Let's see. It was Tarzan versus Snow White. Because we're doing like all basic animated movies pretty much for animated movies. So Tarzan or Snow White? What do y'all think? Okay, we got 8 for Tarzan, 2 for Snow White. Did y'all know that Snow White was the first animated princess movie, or maybe animated Disney movie of all time? I can't remember. I think it's the first animated princess movie.
She's also the youngest. She's only 14.
Seriously? She was 14? Okay,
Yeah,
we got to go for Tarzan here. Kidding.
Yeah, we gotta get the FBI call.
It's 2022. We can't do that.
Yeah, FBI is on the. They have us on the list.
First fact, do you guys remember the end of the Snow White movie when that clearly adult prince kisses her dead body?
Yes, that's a big part of it.
Am I the only one who finds that weird?
I mean, that's part of it, yeah, for sure, since she's 14 years old here. Okay, we're going to end this one with Tarzan definitely winning. We're going to do one more before we start today. So we're going to do favorite movie, and we're going to do Lion King versus Ralph Breaks the Internet. Which, anyways, I don't even think I need to say anything about this one. Wait, I need to launch it. Hold on. Hey, Thomas, how are you? Hey, Adam. Okay, Lion King versus Ralph Breaks the Internet. This is unfortunate for Ralph Breaks the Internet because Lion King is like so high up there, you know? So it's hard to even know who really, like, it still may be a good movie, but Lion King is going to win, right?
Well, you know, Mufasa dies.
Right. It's Lion. You can't vote against Lion King or else.
Yeah, I mean, if you're a child who has watched Lion King and haven't cried during that scene,
right?
No, fam, I don't mess with you.
Okay, we got 1 for Ralph Breaks the Internet and then 18 for Lion King. I don't think Ralph Breaks the Internet is going to have a comeback, but you know what? I don't think I've even seen Ralph Breaks the Internet, and I need to watch it. Okay, that was our last one for today, and we're going to do the rest later. So thank you guys for participating. We're going to get through this this bracket. We'll have to go quicker, or we'll have to compromise on and get through more, because I really want to know who the ultimate winner is going to be for you guys, because I feel like every group is different. And so I want to know, like, within this group, what's the most popular. And I feel like every year the movies are going to be different. Okay, let me share the link for live class today. As always, it's great to click on it, even if you don't like stay on it. Just click on the link, because then it automatically saves it to your Google Slides. You can always go to like, hold on. Hey, Valerie, how are you? You can always go to your Google Slides by going to www. I'm going to put this in the chat. You can go to slides.google.com, and every slide that you've ever opened, it's like history in your slides. And so if you click on this, you'll have it, and you'll be able to use it later if you want to. So click on that link if you want to save this. And we're going to get through some chemistry today. I hope y'all had a great weekend. I'm loving the weather, so I hope that y'all are too. I know it's like kind of cold. A couple shout outs. I just logged on and looked, and I saw people who have already logged into chemistry today. 9 students today have logged into the course. Okay. And I want to see what else. So put an emoji in the chat if you submitted assignment yesterday, even not today, but yesterday, if you turned in an assignment, not if you logged in, but if you turned in, like you finished a lesson, you finished a quiz, you finished a test. Put an emoji, or if you don't have an emoji, just say me in the chat if you want to share. Okay, Emery, Aaliyah, great job saying. Braden, Emily, y'all are awesome. Okay, Sadiq, Thomas, I don't know if that's a yes or a no. It's just put something in the chat if you turned in a chemistry assignment yesterday. Okay, anybody else? Oh, you didn't have Wi-Fi. That's okay. Nathaniel did. Natalie did. That is awesome. Way to go, guys. I'm super impressed. Selena, that's an upside down smiley face. I think that's a yes, though. That's awesome. Allison's like, I don't remember, but I think I did. Piper, Logan, great job. Meche, you definitely, I think it was, oh, maybe it was Monday, but I think you should count because you did a lot of stuff on Monday. That should definitely count. Okay, put an emoji, put a 100 emoji in the chat if you submitted an assignment today. I don't know if anybody has yet. It's only 11 a.m. Or put just a me in the chat if you submitted something today in chemistry. Okay, Sadiq. Okay, he was working on a quiz. That's awesome. Aaliyah did already. Natalie, Daniel, Emery, you got 5 questions left. You're close to submitting one. Okay, we've got some active students in class. I'm so impressed. Super impressed with you guys. I'll shout out next week as well. So make sure you submit some assignments this week and next week, and we'll do some more shout outs. Or you can tell me what you did, because I'm always super impressed when I hear from you guys. Okay, here again, if you have not downloaded the periodic table, please click on one of these that you want to download. I recommend the black and white version, and download it. And if you have a printer, then print it. And that way you can label it and things are less confusing as you go through the course, because sometimes online stuff is just like so much information, right? If you can have a physical copy of the periodic table, it will help you be less confused. And I'll have you write on it or whatever if you tell me that you've printed it. Even if you don't print it, just save it to your Chromebook. And that way you have it to look at and you can color on it later. Okay. If you have not clicked on this folder, this will help you with all of the tough lessons. And so click on that link if you want access to this resource folder. It has all sorts of things that I'm adding to it every single day to help you guys out based on how I see that y'all are doing. I'm like, oh, a lot of students need help with this lesson. I'm going to put a resource in here and give some of the answers or explain how to get the answers. So make sure you save that. Last week, we talked about periodic trends and we talked about some principles. We said, protons are attracted to electrons. Electrons are repulsed by one another. So they are opposite. Opposites attract. And so if they are both the same charge, they're kind of repulsed by one another. They repel each other. And then we learned that atoms like to have a low energy state for any situation. We learned about atomic radius. And just to show you the general trend, it increases going to the left and down. So the radius of an atom gets bigger, bigger, bigger compared to each element going to the left and going down for atomic radius. You can save this picture if you want to for your tests. We did some practice last week, if you remember, okay, if something gains electrons, what charge is it going to have? And so in this situation, if you gain 3 electrons, we said that, okay, you're going to have a -3 charge because electrons are negative. So if you accept negativity, you're going to become more negative. Okay. Another example that we did, and the last thing we talked about was ionization energy. It increases going up and to the right. I'm sorry, this is the trend right here, up and to the right. Electron affinity also has the same trend, up and to the right. And electronegativity also has the same trend, up and to the right. And so most of them are going up and to the right there. And that's kind of what we learned about last week. This week, we're going to learn about bonding, okay? And we're going to learn, basically, this is like, I would love for all of you to kind of have an understanding of this, even if you don't go into chemistry in the future, but you go into some other field, to know like how like a table is a table, you know what I mean? And how like matter works is important to know. And basically elements like to form what we call bonds. No, sorry, that's my dog barking. Nobody. They like to form bonds by sharing electrons. And so they'll gain electrons or lose electrons or share electrons with another element, and they'll form these bonds, okay? There are 3 main types of bonds: covalent, ionic, and metallic. And we're going to talk about covalent and ionic today. So a covalent molecule, let's look at the situation here. We have H and we have O. And you see how their electrons are? That's kind of how they start off. That's how many electrons they each have, right? H and O in this situation are not happy. Does anybody know why they're not happy here? This is before they've bonded. Why are they not happy? Any guesses? Any thoughts at all? Y'all are like, I don't know. That's why I'm here. They don't have enough dots. Emily says, okay. They don't have enough. Allison says that. Okay, y'all are on the right track. So the reason they're not happy right now is because they want to have full shells. They want to have full shells. How many electrons can hydrogen fit? Megan, great job. They don't have a full 8. How many electrons can hydrogen fit? Does anybody know? Close. So on the first ring, they can fit 2. Do you see how oxygen has 2 in the first ring right here, right? The first ring can only fit 2. So hydrogen is not happy because it only has 1. Oxygen can fit 8, like Megan said. Every other element besides hydrogen and helium, every other element wants to get to 8 outer electrons. Right now, oxygen has 6. 1, 2, 3, 4, 5, 6 outer electrons. So guess what they do? They share. And so look now, hydrogen now has 2 because oxygen is sharing one of its electrons. So it now has 2. And then oxygen has 8 on the outer, 2, 4, 6, 8. So now they share electrons so that they all have a full valence shell. This is how the world works. This is how atoms form bonds everywhere that you see. They form bonds to share so that they're happy and stable. So now they're stable, and we've got water that we can drink. All of the water in here is made up of H2O bonds that are sharing electrons so that they have this bond formed together, right? And this is called a covalent molecule. Covalent bonding happens when everything is a non-metal, okay? And what happens is the electrons are shared, okay? So 2 things. Electrons are shared. They're shared evenly, and it happens between non-metals. So let's look at the periodic table here. Y'all see the red, the blue, and the yellow, okay? So which ones are non-metals? Red, blue, or yellow here? What do y'all think? Just real quick looking at this, which ones are the non-metals? Blue, right? Thank y'all. Great job. Y'all are on top of it, right? So for something to be covalent, if you could write this down, if you take notes, this should go in your notes section. Covalent bonds can only happen if the elements are non-metals. Okay, covalent bonds can only happen if the elements are non-metals. So only the blue, right? That's for covalent bonding. And so H2O, when you find it here, here's H right here, and here's O. They are both non-metals, and so they can have a covalent bond, okay? What else do I have here? Yeah, so they only happen when all of them are non-metals. So here's some examples of covalent bonds because all of these are non-metals. All of these examples here are covalent bonding. Does that make sense to everybody? Y'all feel like you understand how you figure out if it's a covalent bond and kind of what it does? Hopefully the pictures help a little bit. Okay, we're going to learn about Lewis dot diagrams. So let's take one strip of the periodic table. Okay, so look at that first strip that I have here. We're going to take that strip and we're going to look at it a little bit more closely. Okay, so I'm just taking that and I'm zooming it in, right? So remember that Li is from group 1, Be is from group 2, B is from group 3. So I'm just taking that and putting it down here, okay? If I were to draw these electrons, which I did, which took a while whenever I originally did it, these are what they look like. So how many, when you look at Li, how many outer electrons does Li have? Look at the outer electron only. 1. Great job. What about Be? How many outer electrons does Be have? 3, right? I mean, 2. I said 3. Sorry, 2, right? You can count the outer ones only. So they're kind of like that different color. And then for B, for boron, how many does it have? For boron? 3, right? Yeah, sorry, Allison. Yeah, you're looking at B. Okay, do you see a trend here? It goes 1, 2, 3, 4, 5, 6, 7, 8, right? So when we ask you to draw the dot diagram, okay, you're going to see this on tests and on quizzes. You draw dots to represent how many outer electrons they have, only the outer electrons. So look at how the dots go here. So Li has 1 dot for the 1 outer, Be has 2 dots, boron has 3 dots. You draw dots to represent how many outer electrons that they have. And so you need to put this on your periodic table, and you can look at either of these. It shows you the same thing, right? I just showed you a different way. But group 1 has 1 valence electron. Group 2 all has 2. You skip the yellow transition metals. You're going to skip this section. And then you keep going from here. And that tells you how many outer electrons they have. It is extremely important. It's going to build on this in chemistry. And then when you take chemistry in the spring, it's also going to build on it. So if you have an organized periodic table on your Chromebook where you have this listed or you save this picture, it's going to help you because you have to use this throughout the course. So this is how many valence electrons that they have. So you can come back to this slide and look at it if you want. You can also look at it this way. It's whatever works for you. We're not going to talk about how to write Lewis structures in this lesson today, but I made a tutorial video on it. And so if you want to learn how to do Lewis structures, know that I have a video on my YouTube channel for it. Now we're going to learn about ionic compounds, okay? So an ionic compound happens when one element is a metal and the other element is a non-metal. Okay, so going back, let me go back to this picture right here for a second. So ionic bonding happens when you have a metal and a non-metal. So what 2 colors are involved for ionic compounds? What 2 colors are involved here? Red and blue, exactly. For an ionic compound to happen, you've got to have 1 from the red and 1 from the blue. And the red is always listed first. So the first element is going to be the red one and the second one is going to be the blue one. You need to write down the main difference between ionic and covalent because there will be a lot of rules that come from that in the further units in chemistry. Okay, so ionic and covalent. So now we're going to go back to ionic here. What happens here is if you look at the situation, the metal is going to donate its electron and it forms what we call ions. An ion is something with a charge. Do y'all see how they both have a charge, a +1 and a -1? Those charges are called ions, which is why this is called an ionic compound. Okay. The important thing about ionic compounds is that the net charge has to equal 0. Okay. This is telling you a little bit about ionic compounds, like how they work. They form this really strong structure. If you look at this picture here, it shows you kind of what happens. Like think of table salt. table salt at a molecular level looks like this, which is really strong. And so they have really high melting points, like 1,000 degrees to melt, like 1,500 degrees actually, because they're so strongly bonded together. And so that crystal lattice structure is really kind of cool for that. We are going to practice how to write a formula for it. You also are going to need this chart, and it tells you the charges that elements can take on. This is very important. And so you can write it down on your periodic table or save this picture, but you need to know the charges of elements, okay? So we're gonna do some practice together. So you can click on this Jamboard link, and I'm gonna do this with y'all. And let me share the link, and we're gonna do a couple real quick before we wrap up today so that you feel like you know how this works. Let me share the link with you guys though. Okay, here we go. Here is the Jamboard link. We're gonna do some practice real quick. So everybody click on that link if you want to, or you can just keep watching from here. But we are going to look at these steps together. So here's how we're gonna write a formula, and I'm just gonna kind of show you with an example. So if I say write the formula for magnesium fluoride, I'm on slide 4, okay? I'm on slide number 4. It might be good for y'all to look at my screen because I'm going like back and forth. So we need to find these elements, okay? So we've got to go to the periodic table and find magnesium and find fluoride. So does anybody know where magnesium is here? What's the symbol for magnesium? Any guesses? You can look and find it there. Who can find magnesium? Thank you, Sadiq. Thank you, Sang. Magnesium is right here. Do y'all see magnesium here? Everybody see it? It's kind of, you kind of got to zoom in a little bit if you need to. Hold on, let me zoom in. You can see magnesium right here. Okay, so I'm going to go ahead and write that down, that magnesium is Mg. Give me one second. Magnesium is Mg. Okay, now for fluoride. Fluoride, if it ends in "ide," it came from something else. So we're looking for fluor, and typically on the periodic table, it's "ene." So whatever it ends with, like "ide," it's not technically "ide" on the periodic table. We need to look for fluorine. So what is the symbol on the periodic table for fluorine? Anybody find it? F. Great job. Do y'all see F on the periodic table here? Here's F right here. Okay, so we have Mg and we have F. Now we need to write their charges. So going to this chart, what charge does Mg have? Looking at this chart right here. What charge does Mg have? Everybody see how Mg has a +2 charge? Great job, Sang. Great job, Emily and Natalie. All right, awesome. What about for fluorine? What charge does fluorine have? Right here. -1, right? It's in the -1 category. So we're just looking at the overall, like what column it's in, right? So Mg is going to have a +2 charge and F is going to have a -1. But the net charge has to equal 0. If we were to add these two together right now, does the net charge equal 0? If we add +2 and -1, does that come out to 0? No, right? +2 and -1, that comes out to +1, right? If we were to add these two together. So we need to figure out how to make the net charge 0. I could add an extra magnesium if I want to make the overall like positive charge be +4. I could add an extra fluorine or 2 extra fluorines. What if I added an extra fluorine? Then my net charge would be 0, right? Do y'all see how if I added an extra fluorine, my net charge would be 0? Y'all see that? Okay, so that means that my formula needs to be MgF2. I need 1 magnesium and 2 fluorines. So your final answer, do not show the charges. The charges are invisible. They are there, but you don't have to show them, okay? You show how many you have of each element. So let's try one more example real quick. Let's try, let's do calcium oxide. We're gonna do slide number 6. So y'all go to the other slides and tell me what is the symbol for calcium and what is the symbol for bromide? Y'all tell me. We're doing, I'm sorry, we're on this slide right here. I'm sorry, calcium oxide. The symbol for calcium and the symbol for oxide. Okay, Ca is calcium. Okay, Ca is calcium. What about oxide? What do y'all think oxide comes from? It's not going to be oxide on the periodic table. We're looking for something that starts with ox. Okay, y'all see anything that starts with ox on the periodic table? You may be familiar with this compound, with this element already. Oxygen, right? This one's kind of weird. It actually comes from oxygen. Y'all see oxygen right here? So that's our other element. So now that we have them, we need to look up their charges. So go find calcium and oxygen on the periodic table. What charge does calcium have? What charge does calcium have? And what charge does oxygen have? We got +2 for calcium, -2 for oxygen. Okay, so let's go ahead and write that down. So +2 and -2. So does the net charge equal 0 the way that it is right now? Does the net charge equal 0? When you add those two numbers up together, do they cancel out and make 0? Yes, they do, right? +2 and -2, they're going to cancel out. So our formula is going to be CaO. We only need one of each because each one has a +2 charge and a -2, and that makes 0. So my formula is just going to be CaO. Hopefully this is kind of making sense to y'all, and I will make a tutorial video on it as well. But for those of you needing to know how to do Lewis structures, I made a YouTube tutorial video on it. So please go watch that if you're struggling with how to draw Lewis structures for your Unit 3 test. And it's on my YouTube channel under Unit 3. I can send that link. If anybody wants it, like raise your hand and I'll put it in the chat if y'all want that. But y'all are all good to go. I hope you have a great week and I'll see y'all next week. Come to my classroom anytime.